Hello, good morning my dear students, and once again, welcome to the world of electronics. Our lesson for today is all about ammeter, specifically DC and AC ammeters. This lesson is still under LX111, which is electronic devices, instruments, and circuits. Both types of multimeters, such as analog multimeter and digital multimeter, will be undertaken today. However, talking about AC ammeter, these two brands of analog multimeters, such as Sanwa brand and Wheeler brand, do not have or they are not equipped with AC ammeter. Unlike digital multimeter, which is Sanwa brand, is equipped both AC and DC ammeter. Okay? Now, let us have first the analog multimeter. When you are using ammeter here, we have here the ammeter DC. There are actually 4 ranges being written here. We have here the 50 microamperes as the lowest range, followed by a higher range which is 2.5 milliamperes, then 25 milliamperes, and 250 milliamperes as the highest range. But just in case you are measuring a higher amount of current which 250 milliampere is not capable, we have still an external or extension range which is actually we have here 10 amperes. We have here 10 amperes. Just below the 250 milliamperes, there is a red color marked as 10 amperes. So, anyway, we will be discussing that one later on as we go along with the ammeter topic, okay? Now, in dealing these ammeter ranges, we have to focus at this meter scale. The same, when you are using the voltmeter DC, this meter scale is still used because this meter scale is for both ammeter and voltmeter DC. Okay? Let us start with 250 milliamperes as the highest range. Okay? When your range selector switch knob is positioned to 250 milliamperes, you have to use this number. Okay? This number, 250 milliampere. 200 milliampere, 150 milliampere, 100 milliamperes, and 50 milliamperes. Then, focus at this black meter scale. Okay? So, what will be the calibration when you are using 250? Again and again, we have to use this formula. Calibration as the value for every division is equal to the range, which is 250 milliampere, over 50 as the number of divisions, because there are actually 50 divisions here. So the quotient now is 5, because 250 divided by 50 is 5. No? Meaning to say that the value for every division here, when you are using 250 milliampere range, is 5. 0, 5 milliampere, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100 milliamperes, so on and so forth until it reaches to 250 milliamperes. Meaning, with this range, the maximum current that could be measured is only up to 250 milliamperes. If in case you are measuring a current in a certain circuit, then it exceeds that amount of range. Let us say you are measuring 280 milliamperes, so this ammeter range is no longer applicable. No? We have to transfer to a higher range, which is 10 amperes over here, because there is an extra range here, which is 10 amperes. We will just, we have here 10 amperes. And when it is set here, just set it to 250 milliamperes. Okay? When the two test rods are connected here, or when this red test rod is connected here, the range you are using is actually 250 milliampere. But when this positive test rod is inserted here, it is no longer 250 milliampere. Instead, you are using now the 10 amperes. 10 amperes, yeah, is a higher unit. No? It is a high unit because 10 amperes, when it is converted into milliamp, that becomes 10,000 milliamperes. 10,000 milliamperes, okay? Just in case the amount of current exceeds that range 250, no? Just in case you are measuring 280 milliamperes up to 10 amperes, okay? So, let us go back to this input line for the 250 milliamperes, okay? So, when this deflection needle or deflection pointer is positioned here, so focus at this meter scale. So that would be 250, 200, 150, 100. Because between 100 and 150, there is still a major division here that is not indicated with value is what? 125 milliamperes, di ba? Between 100 milliamperes and 150 milliamperes is 125 milliamperes. Plus, because the calibration or ang halaga ng bawat guhit is 5 milliampere, di ba? So 125 milliamperes plus 5 milliamperes is 130 milliamperes. So, the reading now is 130 milliamperes. Okay? If it is here, focus at this meter scale again. Still, we are using 250 milliamperes. So, between 50 and 0 is actually 25 milliamperes. So, the calibration of every division is 5 milliampere. So, when let's say, this is 25, this is 20, 15, 10, 5. So, it is 20 milliamperes. Okay? 20 milliamperes. Just in case the pointer is at that position, it is at the middle of the two divisions. So, how do you read it one? Because this is 150, this is 100, this is 125 milliamperes, 130, 135. It is between 130 and 135 milliamperes. Remember that the calibration is 5. Half of that calibration is 2.5 milliamperes, di ba? 2.5 milliamperes. Meaning to say, 125, 130 plus 2.5 is 132.5 milliamperes. So, 132.5 milliamperes. Okay? Or just in case, the pointer doesn't point to the middle, it is a little bit lower, so it could be 132 milliamperes. Or if it is above the middle, 100, let us say, because 130, 135, that is 132.5, it could be 133 milliamperes. Just like that. That depends upon your vision, no? The clarity of your eyes, of course. So, actually, we are only up to estimation kasi. Unlike when you are using digital multimeter. It is really very accurate. Okay? Okay. That's all for the 250 milliamperes. Now, let us proceed to 25 milliamperes, a lower range. Lower range, di ba? So, there is no other number that could be read as 25, but instead, this 350. So, we will read this one as 25, 20, 15, 10, 5. So, When this is 5 milliampere, this is 2.5 milliampere. No? 2.5 milliampere to 1.5 milliampere. 1. Below 1 is 0.5. So, ang halaga ng bawat guhit actually is 0.5 milliampere. Or for sure, use the formula, calibration is equal to the range you are using, 225 milliamperes, divided by 50 is, how much? 0.5 milliamperes. Okay? That is the way how you get the calibration. Okay, meaning to say, 0.5 milliamperes, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 25, 20, 15, 10. 10 milliamperes, so on and so forth until it reaches to 25 milliamperes. Okay? Just in case the pointer is positioned to this meter scale here, over here, that is 25, 20, 15. So the calibration is 0.5 or 0.5. 15 plus 0.5 is 15.5 milliamperes. Plus 0.5 is 16. Diba? 16, this is 16 milliamperes actually. Because 16.5, 17, 17.5, 18, 18.5, 19, 19.5, 20, 20 milliamperes. So, that is how we read the meter scale when you're using the range. Okay? So, 15.5, 16 milliamperes. Or if in case, it exceeds a little, always remember that the half of the calibration, 0.5 is 0.25. 0.25 milliamperes, okay? If this is 16 milliamperes, then medyo it exceeds a little. It is usually at the middle. So, kalahati ng 0.5 is 0.25. So, 16 plus 0.25 is 16.25 milliamperes. Okay? Okay, let us now proceed to 2.5 milliamperes. Lower range. With 2.5 milliamperes, this 250 is read as 2.5 milliamperes. 2, 1.5, 1.5, 0.25, 0.2, 0.15, 0.10, or 0.1, 0.10 or 0.1. Kalahati ng 0.1 is 0.05 milliamperes. Meaning to say that the calibration or ang halaga ng bawat guhit ito ay 0.05 milliamperes when you are using 2.5 milliamperes. Or, for sure, use the formula again. Calibration is equal to 2.5 milliamperes over 50 as the number of divisions. So, it is 0.5. Okay? We have here. Okay? Let us prove whether I am wrong or correct. So, the ratio you are using now is 2.5 divided by 50. The result is 0.05 milliamperes as the calibration. Okay. Now, kalahati ng 0.05 is 0.025. 0.0 kasi if we divide 0.05 by 2, the result is 0.025. So, meaning to say, again, let us clarify. This is 2.5 to 1.5. 1.5. 1.5 plus 0.05 is 1.55. Diba? Because the calibration is 0.05 eh. So 1.5 plus 0.05 is 1.55. Then 1.6.
1.65. So this is 1.6 milliampere. Am I right? 1.65. So between is 1.6 plus 0.025. That is 1.625. 1.625 milliamperes. It is really very confusing. So anyway, there is no difficult when you are always practicing using the multimeter. But just in case it is really very hard for you, then you are in hasty, so you must be provided or you must be equipped also with digital multimeter. Okay? Now, let us proceed to the lowest range, 50 microamperes. This is lowest in the sense that if we are going to convert this into milli, microampere unit is a smaller unit compared to milli. So, you have to move decimal point here 3 places. 1, 2, 3. That becomes 0.05 milliamperes when it is converted into milli. Okay? With 50, we have 50 here. 50 microamperes, 40 microamperes, 30 microamperes, 20 microamperes, 10 microamperes. Meaning this is 5 microamperes, 15 microamperes, 25 microamperes, 35 microamperes, 45 microamperes. You are using 50 divided by the number of division 50, meaning to say that the calibration is 1 microamperes. So, ang halaga ng bawat guhit dito ay 1. 1 microampere, 2 microamperes, 3 microamperes, 4 microamperes, 5 microamperes, 6, 7, 8, 9, 10 microamperes. So on and so forth until it reaches to 50 microamperes. So meaning to say with this range, the maximum current that could be measured is only up to 50 microamperes. No? It is up to 50 microamperes. Then, if you are actually measuring current in the particular or in that certain electronic circuit such as TV circuit, there are lots of currents there. Then you are not familiar yet with the amount of the current, whether it is high or low. So the correct procedure here when using ammeter ranges, then you are not sure yet with the amount of the current circulating around the circuit. So start from the highest range if possible. Start from the highest. If possible, start from 10 amperes. Okay? So, just in case the current is really very high and 250 milliamperes is no longer capable for that, transfer this red test rod over here. Then, in this position 250, you have to use the below level 10 amperes. So with 10 amperes, use 10 as 10 amperes, 8, 6, 4, 2 amperes. This is 1 because between 2 and 0 is 1 ampere. This is 3, this is 5, this is 7, this is 9 amperes. Then, what will be the calibration when you are using 10 amperes? So, again and again, calibration is equal to 10 amperes as the range over 50 as the number of division. The quotient actually is 0.2. It is 0.2 amperes. Meaning, 0.2, 0.4, 0.6, 0.8 plus 0.2 is 1. 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, 2.8, 3, so on and so forth. The unit is always amperes. No? Ampere or amperes. So, if it points here, that is, between 6 and 8 is 7. Then the calibration is 0.2, that is 7.2 amperes. Just in case it exceeds a bit, sumubo lang ng konti. 7.2 and 7.4 is 7.3 amperes. Okay, just like that. Okay. Now, going back to the safety precautions when using ammeter. Before you attempt to measure the current, you have to check first the position of the deflection needle. If you see that the pointer is already set to 0 scale, so there's no need of adjusting the 0 set screw. No? So remember, before you attempt to measure the currents or the voltage or the resistance, see to it that the position of the pointer is set to 0. If in case it isn't set to 0, just rotate the, okay, when you rotate the 0 set screw here, okay, just like that, set and stop at the 0 scale. 0 scale. For sure reading or measurement of the current. Okay? Let us now, how do we connect the ammeter? So it goes like this class. So let us first use 250 milliampere. Actually, different from the voltmeter, because when you're using voltmeter class, when using voltmeter DC, measuring the voltages, you are using 10 volts here because the amount of the applied voltage with this battery is 9 volts. No? Okay. You have to consider or take into account always the polarity of the multimeter when you are using voltmeter and ammeter. Okay? It goes like this. This should be positive for the ammeter and voltmeter in the case of analog. Then, when you are using ohmmeter, this should be negative. And this should be positive for the ohmmeter because remember that among the meters, only ohmmeter is using internal power supply, and that is the battery. You can see the battery there. And this positive and this red test rod is actually connected to the negative side of the battery. That is why this should be negative. Okay? And this should be positive. Now, we are using 10 volts here. This is the way how we connect our test rod. Okay? The pointer should move forward. Okay? The voltage across this resistor, then the voltage across this resistor. No? It should be in correct polarity because once it is inverted, the pointer kicks back in the case of the analog. But in the case of the voltmeter digital, we have heard the selector. The symbol now is DC. But once it is like this, AC. We are going to measure the AC volts. But the voltage, the type of the voltage that is applied here is DC. So change that one to DC. We have here the symbol. Okay? The upper portion, not this one. Okay? When it is in correct polarity, so 1.3 or 1.29 volts. But when it is inverted, it's still the same amount of voltage. But look at the negative sign. We have here the negative sign. Meaning that symbolizes or indicates that the polarity of your test rods is inverted. It should be like this. Look at So, mamaya mawala yung kuan, negative sign dyan. Sign as inverted polarity. So, nawala yung negative sign dyan. Meaning to say that your test rods are already in correct polarity with the applied voltage. We have heard the applied voltage, the battery. Okay? That should be the correct way. Okay? Remember, with this voltmeter digital, the maximum voltage that could be measured is only up to 600 volts. 600 volts. Unlike this voltmeter here, 1000 volts. Okay, we have here 600 volts. Okay, let us 400 milliamperes. 600 volts we have here. 600 volts. Okay, 600 volts we have here. The 600 volts. Unlike this one, analog 1000 volts. It is 1000 volts. Okay. With digital, only up to 600 volts. That is now the capacity of this digital voltmeter. It is only up to 600 volts. Okay? But when you are measuring the current, set it to ammeter. Now, it is DC. But when you are measuring AC, there is a sign here, AC. But remember that this is DC circuit. A DC circuit is applied with DC voltage. DC current also is being circulated around the circuit. It is not AC. So, therefore, set it to DC. We have a DC symbol. Okay? Now, there's a need of disconnecting the one of the terminals. So, actually, the ammeter is inserted in the circuit. We have here, that is 0.02 milliampere. Actually, you can select the range we have here. The range, no? Select the range, whether it is ampere or microampere. Still the same. 0.02 milliamperes. When it is converted into ampere, that becomes... When it is converted into... that is really the one. When it is ampere, so 0.00002 amperes. When it is converted into micro, just move the decimal point to the right 3 places. So that becomes 20 microamperes. Okay? That is the way. Okay? Let us prove whether the pointer is in correct polarity. Okay, nawala yung negative sign dyan. Okay, this should be the current. By the way, this should be the current. 12.85 milliampere. But once it is inverted, na-invert yung polarity natin ng ammeter, there's a negative sign. Meaning to say, there's inversion of the polarity. But, when your ammeter is in correct polarity, meaning to say that the red is connected to the positive side here, nawala yung negative sign dyan, meaning to say that your ammeter is in correct polarity with the circuit. Okay, 12.82 milliampere. Oh, there was a wrong measurement a while ago. So, sorry. Okay? That is the way how we measure the current. Unlike here, we are using analog. Start from the highest range always. If you are not sure yet with the amount of the current circulating around the circuit. So, this should be positive. Then this should be negative. So, it is very difficult for you to read. There's a little reflection only. So, disconnect your test rod from the circuit and change or set the range selector switch to 25 milliampere. Lower range. Now, the reflection pointer is moving higher. So, it is somewhere at 12 point something. It is almost the same with the digital. But, when you are using 2.5 lower range than 25 milliampere, the result would be like this class. Exceeding the meter scale. If you can use that, then it takes longer measuring the current. Wherein the pointer exceeding the meter scale, it would create partial failure of the internal circuit. The internal circuit uses semiconductor devices, which are of SMD, surface mount devices. You can see here that the electronic parts are being miniaturized. Masyadong pinaliit na. And they are really sensitive to excessive amount of current. When the pointer moves and exceeding the meter scale, meaning to say that there is a large amount of current circulating around the circuit of the multimeter, then the semiconductor devices there will be affected. Will be affected. By the time that you will use again this multimeter, the ammeter, it won't indicate anymore the correct amount of current. Just like this digital multimeter here. It is already defective. It is actually defective already, no? So, here, when using this multimeter, DC, it is 12.89 milliampere. That is actually the correct amount of current circulating around the circuit, being measured by this tester. But once you are using defective multimeter, we have here, let us try if this is defective already, whether the ammeter is already defective. So we have here positive and negative. The current is 0.64 milliampere, which is very far from this digital multimeter. It reaches here 12.80 something milliamperes, but here 0.6 milliampere already. It's wrong. Because if you're going to compute the current here using the formula I is equal to V over R, Ohm's law, the amount of the current being measured here is very far from the computation. But with this, it is almost accurate. So meaning to say that this ammeter here is already defective. What causes the defect? Of course, the deflection pointer, when the amount of the current that you measure is exceeding the maximum current that can be measured here. It is only 400 milliampere. But the amount of the current that you measured is probably 1 ampere, 2 amperes, 3 amperes. So it will cause partial failure to the circuit. It is digital. The spare parts here are really digital. Digital circuit. This one is analog circuit. So be careful in using multimeter. Be careful. Okay? So, how about this class? We have here another range which is not indicated here. It is just between 250 milliamperes and times 1 ohm range. We have here 1.5 volts battery tester. When we say 1.5 volts, it is intended only for a battery. Either it is AA or AAA battery. This is AA, this is AAA. The maximum voltage here is probably 1.6 or 1.5. Okay? So, okay, let us measure. We will use this range, this meter scale here, the bad and the good. No? For the battery. Okay? So, this should be negative. It should be incorrect polarity also. The negative side and the positive side. The pointer deflects at the blue color. It is somewhere here. So meaning to say that this dry cell or battery is still good. It is still good. Okay, how about this one? The triple A. It is bad. The voltage is very low. It is no longer 1.5. Instead, probably this is 1.3 or 1.4. It is over here. Somewhere here. It is no longer at the blue color. Okay, let us measure the voltage here using voltmeter. DC. So, It is no longer 1.5. Instead, it is lower, 1.4. Because a new battery will always provide 1.6, but now it's 1.4. So, if you are using weak voltage of the battery here, the result with the ammeter analog, just set that one to times 1 of range, you can learn that the battery is already weak by shorting the toothpaste rods. Then, set the 0 ohm adjuster. If it exceeds the 0 ohm, meaning to say that the battery inside is still good. But, when you set the 0 ohm adjuster, then it is only up to that point. Yung rotation ay sagad na masyado, nasa maximum ka na, then ganito pa rin ang nangyayari sa deflection pointer. So, there's a need of replacing the battery. These two. Because, even without this, you can still use the times 1. Times 1, times 10 ohms, times 1k ohm. But with times 100k or 10k, it's no longer deflecting. Meaning to say that this battery is used for times 10k. 9 volts plus 1.5 or 1.5 is 12 volts. 12 volts actually is used for times 10k. That's why we have here. See? But with this ammeter, with this Sanwa brand multi-tester, it has only 2 dry cell battery or battery, AA. So meaning to say only 2 dry cells are being used by the ohmmeter ranges here. No? Times 1, times 10, times 100, times 1k, times 100k. So, the ohmmeter ranges here are dependent from these 2 dry cells. Meaning to say only 3 volts is being supplied to the ranges of ohmmeter here. Okay? Okay, up to that point, my dear students, by next meeting, we will be discussing all about AC voltmeter. Okay? So, goodbye and thank you for your attendance.